Let's consider molecular orbital theory. This theory is currently in use to describe molecules, and basically what we do is we take atomic orbitals and add them and subtract them to produce molecular orbitals. This is called the linear combination of atomic orbital molecular orbital method. Consider the simplest molecule, the hydrogen molecule. Two hydrogen atoms bonded together. I will label them hydrogen A and hydrogen B. Now let's consider taking the 1s orbitals from hydrogen A and the 1s orbital from hydrogen B, and they are spheres, so I'll just draw a circle to represent them, and if we add them together we will get 1sa plus 1sb, and we can add them, they're just functions, we can add them just like numbers, and we will get something that looks like this. So hydrogen A is here, hydrogen B is here, and what you'll see is between hydrogen A and B there functional overlap. So the electrons can exist anywhere in this, within this area, and so they can exist between the two hydrogens, because this forms the covalent chemical bond that holds the two hydrogen atoms together. So this is the bonding orbital. Now let's subtract the two orbitals together. And if I do that, where they overlap and I'm subtracting, they're going to cancel each other. So they will look something like this. I don't draw very well again, but see what I do here. It's supposed to look the same. This is HA, this is HB, and so between the two atoms there's no orbital. It's been canceled out by subtracting the two. So electrons can't exist between the two hydrogen atoms, and so this is called the antibonding orbital, because the electrons are located around one hydrogen, not between the two. Now if we were to plot the energies of the two orbitals, we would see that the bonding orbital is the lowest in energy, and the anti-bonding orbital is higher in energy. So this is our energy scale here. And put electrons into these orbitals just like we do with a hydrogen atom. So the H2 molecule has 2 total electrons, one from each hydrogen, and so we'd start with the lowest orbital and we start putting electrons in. We can put 2 electrons in each orbital as long as they have opposite spins, and so we designate the spin with an up or down arrow, and so we can put 2 electrons in the bonding orbital. So this shows that hydrogen H2 molecule is net bonding because the electrons are all in a bonding orbital. Let's look at the helium molecule. two helium atoms bonded together. Is that possible? Well, we would do the same argument. We would combine the 1s orbitals on the helium, and we would get a bonding and an antibonding orbital, and we would start putting electrons. Now, helium atom has 2 electrons, so for both heliums, that's a total of 4 electrons. So we'd need to put 4 electrons in our orbitals. Now we have 2 in the bonding, 2 in the antibonding, and they cancel each other, meaning the antibonding cancels the bonding electrons, and so there is no net bonding in helium-2. So this molecule does not exist. The molecular orbital method is a great way of determining whether a molecule is stable or not. Helium-2 is not stable because there's no net bonding. So the 2 helium atoms just float apart. There's nothing to hold them together. Whereas hydrogen, H2, gas, is stable because the 2 atoms are held together by bonding electrons.